Hello everyone and welcome back to another video. This is part 2 of the lesson for the M4 trigonometry outcome. In the previous lesson, we talked about the tangent ratio, where we use the opposite and the adjacent sides. Now, if we don't have the opposite and the adjacent sides, we might have the hypotenuse. Now, we didn't ignore it on purpose in the last lesson, we just happened to not use it. Now, in order to solve a question using the hypotenuse, we just need to look at those questions from a different angle. Now, depending on what we have, we can use one of these two formulas. So either the sine ratio or the cosine ratio. So what's different about these two formulas compared to the tangent ratio as well as with each other is that the sine of angle A is equal to the opposite over the hypotenuse side, and the cosine ratio, or the cosine of angle A, is equal to the adjacent side over the hypotenuse. Now, it seems like it's going to be fairly difficult to memorize these formulas, but we can use the acronym SOHCAHTOA to help us memorize each one of these trig ratios. Now, a cool way to write down SOHCAHTOA to help you remember what goes where is by doing this. We know that the sine is equal to the opposite over the hypotenuse. The cosine ratio is the adjacent side divided by the hypotenuse. And finally, the tangent ratio is the opposite side over the adjacent side. So regardless of what type of memorization device you use to help you memorize these, oftentimes your teacher will provide you with a formula sheet anyways. This is one of those things that even my own friends will still remember, 15, 20 years out of high school. So chances are you probably won't forget SOHCAHTOA even years and years and years after you've used it for the last time. So we can use these formulas the same type of way we use the tangent formula. If we want to find angles, we need to use the inverse function. To use the side lengths, we just need to use the regular function. We don't need that fancy inverse function. Now, two definitions that I want to talk about before we proceed any further are angles of inclination or elevation, which is an angle that is measured up from the horizontal. Now, what does that mean for us? Well, let's quickly take a look at a diagram here. Let's imagine that we are looking straight ahead from our eyes. So this is our eye right there. And I'm going to draw a dotted line that represents our horizontal. So let's call this line our horizontal. And if we are looking upwards, this right here will be our angle, whatever measure that is. That is my angle of elevation or inclination. Now, something else that we aren't going to explore as much, just for the intents and purposes of this outcome for the time being, is that we can also look at the opposite side. Whatever goes up can also come down. This angle right here, if we're only looking, and maybe I'll do this, let's shade this in, and let's shade this in. That is my angle of depression, which is really just looking down from the horizontal. So we can write measured down from the horizontal. Let's work through a couple of examples together. So it says, given the ratio, find the measure of A to the nearest tenth of a degree. So we have sine of A is equal to 0.6872 and cosine of A is equal to 3 over 8. Now these look like they might be fairly difficult questions, but really it just is asking you, what is the angle measure that's related to this ratio? So I'm looking at some sort of angle from a triangle. Don't know exactly what it looks like. I don't know what the side lengths are. But if I were to look at the sine, the sine ratio, which is the opposite side divided by the hypotenuse. And let's say, for example, I take a look at this angle. So let's say this is angle A. Basically, what I'm saying is if I'm looking at the opposite side and I have my hypotenuse here. Now, in order to actually find the measure of angle A, we need to take the inverse sine of both sides. So we get angle A is equal to the inverse sine of 0.6872. So let's punch that into our graphing calculator. So second sine 0.6872. And let's close off the bracket there. And we get 43.4 degrees. So A is equal to 43.4 degrees. Same thing with example B or 1B. If we want to find the cosine or the measure of just angle A, we need to take the inverse cosine of both sides. So inverse cosine of 3 over 8. So we have second cosine, so inverse cosine of 3 divided by 8. If you have a scientific calculator and it's one of those ones that's a little finicky, what you might want to do or what you might have to do is if we divide 3 divided by 8, we get 0.375. You could instead go second cosine 0.375, close off your bracket, and we end up with the same exact answer. So if we round to the nearest decimal place, that's 7, turns out to a 0, so we end up with 68.0 degrees. So A is equal to 68.0 degrees. So we want to solve for angle S in each of these next two examples. So let's go ahead and label angle S in both of these. And then what we're going to do is we're going to label the opposite side. And in this case, we're looking at our hypotenuse. So again, to solve for an angle, all we need are two different sides. I'm not worried about my adjacent side right now, so I'm just going to leave that blank to avoid any confusion. So let's write our ratio. Now, how do we know which ratio we're working with? So we'll use SOHCAHTOA. So SOHCAHTOA. And we see here that we've got the opposite and the hypotenuse. So we need to use our sine ratio in this case. So sine of angle S is equal to the opposite side over my hypotenuse. So sine of S is equal to 23 divided by 35. So I want to take the inverse sine of both sides. So the inverse sine of 23 over 35. Second sine. So inverse sine of 23 over 35 gives me 41.08 degrees. So if we round to the nearest degree, we end up with 41 degrees. So in this question here, let's go ahead and label the sides. So here, directly opposite is my opposite side. My hypotenuse is opposite of my right angle, which is here. So the 18 feet is my hypotenuse, which means that my 12 feet here is my adjacent side. Now, since we're not given a measure of my opposite side, we're just going to focus on the adjacent and the hypotenuse. Which trig ratio uses adjacent and hypotenuse? It will be my cosine ratio. So we're going to go ahead and state that the cosine of angle S is equal to my adjacent side over my hypotenuse. So we have the cosine of S is equal to 12 divided by 18. Now again, because we don't want cosine of S, I'm going to take the inverse cosine of both sides. So the measure of angle S is equal to the inverse cosine of 12 over 18. Let's punch that into the calculator. So second cosine 12 divided by 18, let's close off the bracket, is equal to 48.1 degrees. Let's round that to the nearest whole number, so that's going to be 48 degrees. So the measure of angle S is equal to 48 degrees. So in example number 3 here, it says that a water bomber is flying at an altitude of 5,000 feet. That is just a type of airplane. The plane's radar shows that it is 8,000 feet from the fire site. What is the angle of elevation from the plane, from the fire site to the nearest degree? Now here we need to be really, really careful about reading and interpreting this question. First thing that I'm going to note is that your altitude is 5,000 feet. So your altitude is just measured directly from the ground up. So in this case, we're looking from the plane, and let's draw this as the ground. So this plane is 5,000 feet up in the air. And then it reads that the plane's radar shows that it is 8,000 feet from the fire site. So the question that we have to ask ourselves is, which line or which side of this triangle are we actually labeling as the 8,000 feet? Well, it doesn't mention anything about a horizontal distance, so we're going to go ahead and assume that that 8,000 feet actually represents this direct distance, otherwise known as our hypotenuse from that fire site. So again, my right angle is formed using this side and this side here, so directly across, I will have my hypotenuse. So let's go ahead and figure out where our reference angle is for this question. So your angle of elevation of the plane from the fire site. So we're looking from the fire site up to the plane. So we're going to go ahead and label our angle or our reference angle right there. We have no idea what that is. Let's call this angle F. So we're looking at our two sides that were given, and we want to figure out, well, which trig ratio do we need to use? So if we're looking directly across this triangle here at that 5,000 feet, that will be my opposite side. And then my 8,000 feet happens to be directly across from my from my right angle, so that this becomes my hypotenuse, or it is my hypotenuse. So we're going to look for a trig ratio that has both the opposite side and the hypotenuse. So remember SOHCAHTOA. And the one that fits our need is the sine ratio. So the sine of angle F is equal to the opposite side over the adjacent side. Let's go ahead and fill it in with the known values. So sine of angle F is equal to the opposite side, which is 5,000, over my hypotenuse, which is 8,000. We want to take the inverse sine of both sides, so the inverse sine of 5,000 over 8,000 is what I'm going to type into my calculator here. So we have the inverse sine of 5,000 over 8,000 is equal to 38.68. So we're looking for the nearest degree, so 38.68 will then round up to 39 degrees. So we can say the angle of elevation is 39 degrees. So now that we've used sine and cosine to figure out the measures of various angles, we can use them to calculate the lengths. So remember our acronym SOHCAHTOA, you have sine, cosine, and the tangent ratio. Now, again, a quick reminder, when we're finding those lengths with trig, we need to have one known angle and we need a known side length. So two things that we definitely need to know. If we have an angle and either opposite or hypotenuse, you want to go ahead and use the sine ratio. Notice opposite and hypotenuse comes from sine. And if we have an angle and adjacent or hypotenuse, you want to use the cosine ratio. So let's find the length of side BC. I'm going to highlight it really quickly here. So this is what we're looking for. If we're looking at our reference angle, it happens to be this 50 degrees. So directly across from that is my opposite side. And we're going to try to figure out BC. So my opposite side doesn't actually have too much bearing on this question. One, because we aren't given what this side is, and two, we don't really care what that side is, since we do care about side BC. So let's call this x. Now, since I've already labeled my opposite side, let's label the hypotenuse, and the hypotenuse, again, is directly across from the right angle, and that right angle is angle B. So directly across from angle B is the 5.2, which means that my side length of x, or referring to BC, is going to be my adjacent side. So if we think about our acronym SOHCAHTOA, so let's write it down here. SOHCAHTOA. We're going to be looking at the cosine ratio because we have the hypotenuse and we're trying to find out my adjacent side. So let's go ahead and set up our problem. So we have cosine of C is equal to the adjacent over the hypotenuse. So cosine, and we know what angle C is. Angle C is 50 degrees, so cosine of 50 is equal to the adjacent side, which is x, divided by my hypotenuse, which is 5.2. So I'm going to get rid of that denominator on the right side by multiplying both sides by 5.2. So I end up with 5.2 times the cosine of 50 is equal to x. So we have 5.2 times the cosine of 50, and close off that bracket there. We end up with 3.34. So we aren't told what to round it to. So in this case, since we already have a measurement to the nearest tenth, let's go ahead and round to the nearest tenth. So 3.3, and in this case centimeters, is equal to x, and maybe instead of x, we'll write BC. So the side length of BC is equal to 3.3 centimeters. For this next question, we're going to try to find the length of AB, so it's going to be this side right here. Let's start off with our reference angle, which is the 50 degrees. That means that directly across will be my opposite side. This 5.2 ends up being my hypotenuse, again, because I'm directly across from that right angle. Now, I don't really care too much about the adjacent side here, again, because we're trying to find the opposite side and we're already given the hypotenuse. So let's go ahead and set up our ratio here. We know that we need something to do with the opposite side and the hypotenuse. So we're going to be working with the sine ratio. So before I forget, let's label this as x. So we have the sine of angle C is equal to my opposite side over my hypotenuse. So sine, and we know what angle C is, sine of 50 is equal to my opposite side, which is x, divided by my hypotenuse, which is 5.2. So I'm going to multiply both sides by 5.2. So I get 5.2 times the sine of 50 is equal to x. And let's punch that into our graphing calculator. So 5.2 times the sine of 50. And you guys will note that I've been punching it in using the multiplication sign. You don't need to do that. You can also go 5.2 sine 50. So yeah, 3.98 is equal to x, but since we want to try to round to the nearest tenth here, we can go 4.0 is equal to x, or the side length is side length of AB is 4.0 centimeters. So in question number 3, we're being asked to find the length of DE, which is going to be this side right there. And I'm going to start off by identifying where my reference angle is, which is going to be the 55 degrees right here. Now, something that I get asked about quite often and something that I probably should have touched on a little bit earlier in the video, is why are we not allowed to use your right angle as your reference angle? Now let's think about what's happening with our trig ratios. Because we're using the formula or the memorization device, SOHCAHTOA, to help us memorize those trig ratios, let's go ahead and write it out. So we have SO, which is sine is opposite over hypotenuse, ka, which is adjacent over hypotenuse, and toa, which is opposite over adjacent. We have clearly defined what each ratio is going to be and which sides of the triangle we're going to be looking at. Now, if I were to look at my right angle here, we know that directly across from the right angle is going to be your hypotenuse. That is always a given. Your hypotenuse is always across from your right angle. Now, the problem lies in the fact that because we've defined that as our hypotenuse already, the issue is where we come up with naming the other sides. We also know that directly across from our reference angle is the opposite side, but our hypotenuse cannot be both the hypotenuse and the opposite side. In that case, we would have two adjacent sides. Both of these sides would be my adjacent sides, and the math kind of falls apart there. So the simplest way to help yourself understand why we can't use that right angle is because it causes a lot of problems with the math, essentially. So anytime you're looking for a reference angle, do not use that right angle. So now that we've found that reference angle of 55 degrees, we know directly across from it will be my opposite side, which in this case is the 6.8. And because we're looking for our hypotenuse, we're going to go ahead and identify which trig ratio uses both the opposite side and the hypotenuse. So for us, that's going to be our sine ratio. Let's go ahead and start off with a formula. The sine of angle E, because that's our reference angle, is equal to the opposite side over the hypotenuse. So let's go ahead and fill in our known variables. So we have sine of 55, because we know that angle E is 55 degrees, is equal to the opposite side, which is 6.8, divided by our hypotenuse. And because we don't know our hypotenuse, let's go ahead and give it the variable x. Now what we're going to do is we are going to cross multiply, or really just multiply both sides by x. And I'll just write it down here. We're going to multiply both the top, or rather not the top, the left and the right side by x. And we are left with x times the sine of 55 is equal to 6.8. Now we need to divide both sides by the sine of 55. And we are finally left with, and I'm running out of room there, x is equal to 6.8 divided by the sine of 55. So let's punch that into our graphing calculator. So you've got the 6.8 divided by the sine of 55. And let's close off that bracket there. And we have 8.3. So we have x is equal to 8.3 centimeters. Now again, a really quick way to check your work, just to make sure that you haven't gone off the deep end, is we know that our hypotenuse always has to be the longest side of our triangle. So if you get something smaller than 6.8, you know you've done something wrong. You should go back and check all of the steps in your work. Here in example number 4, we're going to try to figure out the length of JK. So let's highlight what we're looking for. And then we're going to look at our reference angle. So since our reference angle is 65 degrees, directly across from that will be my opposite side. And since we are looking for JK, that is directly across from our right angle, that will be our hypotenuse. So since we're looking for that, let's call that x. We can start off with our formula that we need to identify. So since we're looking at the opposite side and the hypotenuse, once again, we're going to be using the sine ratio. So sine of angle K is equal to the opposite side over the hypotenuse. So you have the sine of 65, because we know that angle K is 65, is equal to the opposite side, which is 7.6, divided by my hypotenuse, which is x. Once again, let's go ahead and get rid of our denominator by multiplying that x onto both sides. So we get x times the sine of 65 is equal to 7.6. We can then divide both sides by the sine of 65. And we're left with x is equal to 7.6 divided by the sine of 65. So 7.6 divided by the sine of 65 degrees is equal to 8.385. If we round this to the nearest tenth, we will end up with 8.4. X is equal to 8.4 centimeters as our final answer. So in example number 5, it asks us, how far is it from the transit to the survey pole? So what we're going to be looking for is this side length that I'm going to highlight or emphasize with the red there. So from the transit to the survey pole. So what we're going to do is identify, again, our reference angle, which is right there, the 46.5. And we know that because that red side is directly across from my right angle here in the corner, this will be my hypotenuse. We know that directly across from your reference angle here in the corner is going to be your opposite side. And the 110 here ends up being your adjacent side. So again, with your trig ratios, so ka, toa, how do we know which one to use? Well, we need something with hypotenuse, so automatically we can get rid of your tangent ratio. We don't need that. And between your opposite end and your adjacent side, well, we need to know at least one side length, so that gets rid of our opposite side. So that means we are going to be using the cosine ratio. So the cosine, and let's call your transit reference angle t. So cosine of t is equal to the adjacent side over the hypotenuse. So since we don't know what your hypotenuse is, let's again call that x. You can really call it any variable you'd like. So you have cosine of 46.5 is equal to your adjacent side, which is 110 meters, divided by your hypotenuse, which is x. So again, we're going to get rid of the x on both sides by multiplying both sides by x. So we're really multiplying by x and multiplying by x. So you have x times the cos of 46.5 is equal to 110. Then let's divide both sides by the cosine of 46.5. Now finally, we're left with x is equal to 110 divided by the cosine of 46.5, and put that into the calculator. So we have 110 divided by the cosine of 46.5, and we end up with 159.8. So because it doesn't ask us to round to a certain decimal place, let's just round to the nearest tenth. X is equal to 159.8, and this is going to be in meters. Question number 6, it asks us, how far is the plane from the radar station? So if we're looking from the plane to the radar station, we can see that we're really just looking at this distance right there, and it tells us it's the required distance. And we're given this side length of 35.6 here at the bottom. So again, our first step is to identify our reference angle, which will be right here in the corner. Directly across from that is the opposite side. We know that here is going to be my hypotenuse. Again, it's directly across from your right angle. And we have this side, which will be your adjacent side. So two things that we need. We need your hypotenuse because it is what we're trying to find out. So let's call that side length x. And we need to know one more side length. So we don't know the opposite side, so we're going to have to go with the adjacent. So again, looking back up at SOHCAHTOA here, since we need adjacent and hypotenuse, we're going to be using the cosine ratio. So since our radar station is right there, let's call this r. So cosine of angle r is equal to the adjacent side over the hypotenuse. So cosine of 32.5 is equal to your adjacent side, which is 35.6, and your hypotenuse, which is x, leaves us with this equation. Once again, let's go ahead and get rid of that denominator of x by multiplying both sides by x. And we get x times the cosine of 32.5 is equal to 35.6. We can divide both sides by 32.5, or divide both sides by the cosine of 32.5. And we're finally left with x is equal to 35.6 divided by the cosine of 32.5. So we got 35.6 divided by the cosine of 32.5. And that gives us 42.2. So we have x is equal to 42.2. And something that I realized we forgot to do is to add sentences to both of these questions here. So how far is the plane from the radar station? The plane is 42.2 kilometers away from the radar station. And for our previous question, how far was it from the transit to the survey pole? The transit pole, or the transit, is 159.8 meters away from the survey pole. So our last section in this outcome is to figure out how to solve triangles. Now, to solve a triangle, it means to find all of your unknown sides, every single one of them, and all of your unknown angles. So basically, you're trying to figure out everything in a triangle. Now, again, you need to understand the difference between solving for a side or an angle versus solving triangles. So hopefully that clarifies some of the questions you might have for your teacher if they ask you to solve for a triangle or solve for a side or an angle. So three strategies or three tools we can use to help us do all of this is any of our trig ratios. Remember, we have your SOHCAHTOA. So we have sine, which is opposite over hypotenuse, cosine, or ka, which is adjacent over hypotenuse, and toa, so that's tangent, which is opposite over adjacent. You can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And last but not least, your triangle sum. We know that all three angles in a triangle add up to 180 degrees. Now, you don't need to use all three tools for every single question that asks you to solve a triangle. It's really up to you, whatever you're more comfortable with. So let's go ahead and solve these two triangles. So for the first one here, again, it's really up to you to decide what you want to start off with. I would like to solve for side AC. And what we can do is we can, maybe before I do anything else, let's write our ratios down. So TOA. And again, as you progressively get better with trig ratios, you might not need to write SOHCAHTOA at the top of every page. But again, just as a visual aid for you guys in this video, we're going to start off by identifying our reference angle, which is right here. Directly across from it is my opposite side. Our yellow side there that we need is our hypotenuse. We don't really need that other side. We can, if we'd like, call it the adjacent side. But since we know our opposite side and we're trying to find our hypotenuse, and let's call that x, we can use something that works with the opposite and the hypotenuse. So in this case, we're looking at our sine ratio. So the sine of angle C is equal to the opposite side over the hypotenuse. So sine of 35 is equal to 15 over x. Let's multiply both sides by x to get rid of that denominator. So you've got x times the sine of 35 is equal to 15. We can divide both sides by the sine of 35 degrees. And we end up with x is equal to 15 over the sine of 35 degrees. So we got 15 over the sine of 35. And we end up with 26.15. Now, since we've solved for this one side, typically what would happen is you'd say that 26.2 is your one side length, and that would give you your answer. Now, you do want to be careful when it comes to rounding for multi-step questions. Do not round your answers until the very last step of your problems. So what I mean by that is if we were to use this value later on in another calculation, you'd want to go at least 2, probably 3 decimal places just to make sure you don't have any rounding issues. Don't round all of a sudden to 26. Don't round to 26.2 preferably. So I'm going to go ahead and depending on what you want to do, we can use this as 26.151 for now. We have x is equal to 26.151. So because I will save Pythagorean theorem for the next question, I'm going to go ahead and just say we're not going to use this side length anymore. We can just round this to 26. Just to keep up with the fact that this is 15 centimeters, let's keep this as a whole number. So our next goal is to find out what my adjacent side is. So I want to figure out this adjacent side. Let's call this y. And we're going to use our opposite side. Now, again, if you wanted to use this side, you could, but you'd want a really accurate measure. You don't want something that you've already rounded. So I'm going to go ahead and use what is already given. So adjacent and adjacent and your opposite side means that we're going to be using our tangent ratio. So we have the tangent of angle C is equal to the opposite over the adjacent side. So tangent of 35 is equal to 15 over y. So we're going to get rid of the y by multiplying both sides by y. And we have y times the tangent of 35 is equal to 15. Once we divide both sides by the tangent of 35, we end up getting y is equal to 15 over the tangent of 35. So 15 divided by the tangent of 35 gives us 21.4. So y is equal to 21.4. If we round that to the nearest whole number, that'll give me 21 centimeters. So let's go ahead and put boxes around these so we can pick out where our final answers are. And the last thing that we need to figure out is this angle right here, and maybe I'll do that in a purple. So what is this angle? Well, we can use the triangle property where we know that all three angles add up to 180 degrees. So we can start out with 180 degrees. We're going to subtract what we know. We can subtract that 35. And then we can subtract this right angle, that 90 degrees in the corner. So 130 or 180 minus 35 minus 90. That leaves us with 55. So 180 minus 35 minus 90 gives us 55 degrees. So we can say that angle A is equal to 55 degrees. So we have solved for all angles and all sides of this triangle. So for that second problem on the page, I'm going to give myself a little bit of room, go a little bit further down. So I have a few different options here on what I want to do. So since I want to use Pythagorean theorem, let's go ahead and do that. We are going to try to look for side JD. So since we're going to look for this side here, directly across from E, or from angle E, is going to be my lowercase e if we're following triangle naming rules. So we know that we've got a squared plus b squared is equal to c squared. That's my typical Pythagorean theorem. Since we're not using triangle ABC, we're using JED. We can call this J. We know that's E already, and D will be up here. So the two sides that I'm adding up will be my non-hypotenuse sides. So I've got D squared plus J squared is equal to E squared. So let's go ahead and plug in those variables. So 6 squared plus 10 squared is equal to E squared. This gives me 36 plus 100 is equal to E squared. And we have 136 is equal to E squared. I don't want E squared, I want just E. So in order to do that, I need to figure out the square root of 136. And the square root of 136 gives me 11.66. So because we're dealing with whole numbers, I can go ahead and round this to 12 if I'm not using it anymore, but I'm going to keep that 11.66 for the time being. My next thing that I want to figure out, I want to go ahead and figure out what angle J is. So angle J, we can use a trig ratio to figure this out. So we've got my opposite side here, if we're using our reference angle. So angle J, we have our opposite side. We know that your hypotenuse is going to be this side, which means that over here will be my adjacent side. So since we're looking at opposite and adjacent, we're going to be using the tangent ratio. So tangent of angle J is equal to opposite over adjacent. So we have tangent of J is equal to 10 over 6. Now we want just angle J, so I'm going to go ahead and take the inverse tangent of both sides. And we're going to head to our graphing calculator. So we have the inverse tangent of 10 over 6 gives us 59 degrees. So angle J is equal to 59 degrees. Now we could do the same thing. We could use this as a reference angle, and we could have this be the opposite side. This is my adjacent side, and use tangent again. Or we can just simply use our triangle property, where we know that 100 or all three angles of the triangle add up to 180 degrees. So let's go ahead and do that. So you've got 1, 2, and let's figure out the last thing that we need to figure out. So 180 minus 90 minus 59, and this gives us 31 degrees. So we have angle D has to equal to 31 degrees. So that's it for today's lesson. Hopefully you guys came out of this with a new appreciation for trigonometry. Unknown to a lot of people, various professions do use it, such as arborists, oceanographers, even construction workers use trigonometry all the time, but maybe you just don't quite see it. Thanks again for watching. I'll see you guys in the next video.